Welcome to KubeCon North America 2020. We are super excited to have you visit Citrix virtual booth. This is Crystal. I am a product manager on the Citrix Cloud Native team. We build a cloud native stack to help platform teams with microservices app delivery in Kubernetes. In this video, Pushkar Patel, product manager at Citrix, will talk about how our multi-cluster solution delivers resilient and secure Kubernetes application. You will learn what is multi-clusters, what are use cases that we are addressing, and we will give you a demo on how it works on OpenShift and Kubernetes. Please take it away, Pushkar.
So I'm going to start by just introducing, what is this multi-cluster and how does it fit into our portfolio. You have seen this picture before. We showed you those 6 components: CPX service mesh, ingress controller, IPAM, observability exporter, node controller. Along with that, there is one more controller which we are introducing. This is for supporting your multi-cluster environment for Kubernetes, right? So we call it multi-cluster controller. So if you have 2 Kubernetes clusters, you will have 2 multi-cluster controller pod running in those, and it is designed to work, on-prem. So you could technically have, data centers which are not part of public cloud across different failure zone, and you can use this, or you could have a hybrid multi-cloud environment where you could have a on-prem Kubernetes cluster and a Kubernetes cluster in the cloud. Either bring your own Kubernetes cluster in the cloud, or you can use the services which are quite famous, which you could use, and we can still tie them together. And this is because of our presence in various cloud vendor marketplace, and also our footprint in the on-prem data centers. We deliver this multi-cluster solution. There are 2 key components to it, 2 CRDs which we have developed. So one CRD called as GTP, or Global Traffic Policies. Basically, this tells you, what kind of method you want to use for your load balancing. Do you want to use canary? Do you want to use, say, a failover option, or you want to use RTT based or local first? That kind of information is embedded in this CRD. Along with that, you can specify your domains. So typically, this is a DNS-based solution. So you would have domains on GSLB, which you need to specify, and GTP is the instance where you would specify that. Also, we support different monitoring, app monitoring, health monitoring of your application. So we have HTTP, TCP, and UDP, which we support. I think there is also SLTCP, but we support all those monitoring, and even that what monitoring should happen is specified in the CRD called as GTP, right? And typically the goal of your application, or the copies of those applications which are spread across these multiple clusters, are either exposed to the outside world, outside the cluster, using either a service type load balancer object of Kubernetes, or using the ingress object. So this second CRD, which is GSE, which is Global Service Entry, is responsible to identify those endpoints. So basically, the CRD dictates the endpoint information for Kubernetes objects like service type load balancer or ingress. So these are the 2 main components of this multi-cluster solution, along with the controller which I showed you in the previous slide. All right. So use cases. So use cases are pretty simple, right? So I kind of explained this at the start. Typically, you go to any customer environment today, right? They don't have just like one Kubernetes cluster. They usually have multiple Kubernetes clusters. Also, they have a requirement of certain applications which are core to their business to have high resiliency. What it means is they would want to have copies of these applications in multiple failure domain, right? The second case is simple. You want to do some kind of cloud bursting kind of a situation where, if your core application is running your on-prem data center and for some reason it goes down, you would want to, take it to, say, a cloud provider, right? Like in this example, I'm showing Azure, which is a choice here. So basically, we'll support this hybrid cloud environment as well. And the logo which you see over here, Citrix, is is an appropriate form factor. This could be, you know, your MPX running in the data center, and it could be a VPX running up in the Azure cloud, right? So this is supported. Also, of course, the multi-cloud environment, where you could have, you know, two separate clouds, and you could still use our multi-cluster solution across these environments. And these are all the different type of deployment we support, right? So we support local first. We can do canary, where you can say that, you know, a particular data center has less capacity, so let me just send less traffic to that compared to the other one, so that way a proper load sharing is done. Failover is by far the most common use case, where you have an active backup kind of an environment where one data center fails and you can send it over. RTT based helps you localize, like whoever gives you a better response from the location you are trying to access an application, I can provide you based on the RTTs. Or you could use a normal round robin technology, where, you know, as the traffic comes in, depending on when it comes in, it could be, you know, one or the either cluster. That's where the traffic is routed to. So I have two clusters. I have one OpenShift cluster. It's located on the east zone in my data center, and then I have a Kubernetes cluster, which is located in the west zone in my data center. And I'm going to use a failover method, where I'm going to take make OpenShift as the primary, and then I'm going to fail that OpenShift cluster, and you will see that the traffic is automatically routed to this west data center, which is Kubernetes. So this is my OpenShift. As you can see, this is the OpenShift cluster. This is my Kubernetes cluster. Okay, the one in red color is my actually east OpenShift cluster, and the one on the right is that my west Kubernetes cluster. And these are the associated VPX with that. So I'm just going to do show NSIP. As you can see, I have assigned 229 as the GSLB for the SNP for that. Same here. This is the VPX associated with the West data center. So this is too many of them. So let me just grep for GSLB. Okay, so you can see that 10, 217, 2121, 248 is enabled for GSLB. Okay. And I already have few applications running, which I want to provide a, sorry. So I have this app one, which is already running, and I already have CIC running, which is kind of going and configuring this app to have access to an individual location, right? It has a VIP associated with that. It can go access this app one over here, same over here. Right, so if I do kubectl get pods, you can see that I have this app one, which is a copy of the same application, which is running in this another cluster. So what I'm going to do next is I'm going to go to this deployment builder, which we just created. So I'm going to go to this multi-cluster option. We provide two choices. If you are starting out your deployment with no ingress controller at all in the Kubernetes cluster, we provide you this option. So you can pick this one. In my case, I already have an ingress controller running. So I'm going to pick without ingress controller. So I'm going to click that, and I'm going to start filling the information. Right. So none of these fields are mandatory. I just want to make sure that any vServers are created has a GSLB tag to it. So I'm just going to use that over here. So let's start by specifying. So there are two Kubernetes clusters. That means I'll have two GSLB controller. So I need to provide right information about who is local, where this controller runs. So let me start with the OpenShift one. As you remember, it was in the east location, and it was an OpenShift cluster. And then I'm going to add data to it, right? So what is this site information? I can provide that site information. So my site name, and let's, for the sake of it, let's say it is OpenShift. I had already created a site password for that. So I'm just going to say site password. If you remember the SNP over here, which is this guy, 229. So I'm going to take this. I'm going to use that as in site IP. Again, this is in east location. right? So this is one side of the cluster who is my local, but there are two sites associated. So I'll have to add another site. So let me just go here. So my second site is actually Kubernetes, right? And it of course has site password 2. I already pre-created it. And then let's look at the snip over here, which is this guy, GSLB snip. I'm going to take that, copy it over. And then of course, this is in the west location, right? And I probably don't need CRDs because I already installed. So basically this has created this values.yaml, as you can see, GSLB enabled equal to true. This was all automatically created based on it. So I'm just going to copy this over. So you can see here, I have a cluster running and I'm going to do, so I have this values.yaml, which should match what I have here. So you can see here GSLB is true, controller is this, and then I have site password 2 and site password 2, east and west. So you can see that it is pretty similar, right? So now what I'm going to do is I'm going to do an install of this. So I already followed this instruction over here, which is do a Helm repo add of these charts. And I'm going to create my multi-cluster with this values.yaml, Helm install. My name is multi-cluster over here. This is my chart, and I'm going to use this values, right? So I'm just going to go here, Helm install values.yaml. Okay, so if I do OC get pods, you will see that the GSLB controller was deployed. So you will have to repeat this same procedure for the another site, right? So basically what changes over there is just the locality, right? So the another site where you're going to run this controller is going to be west, is going to have Kubernetes, right? The other information about the site and everything remains the same, right? They have to discover each other, etc. So only change is this guy, my local region and local cluster has changed. And I have already done that over here. I'm not going to repeat it. So I already have a GSLB controller running over here. So now we have GSLB controller running on both sides. Let me show you my traffic policies here, right? So I'm just going to go. So this is my traffic policy for app 1. I'm going to have primary, the OpenShift environment. And as you can see, primary is false on this one, and I'm going to use a failover method, right? So this is the traffic policy which I have applied. Also, you can also, I also wanted to show you the service entry aspect. So if you can look at the service entry, I'm just telling, the VIP for that particular application, and this is the name which it needs to be associated with. So let's run some traffic. Right, so I have this, I have a curl command. So basically what this curl is doing, what this curl is doing is accessing this app1.example.com, and it is just providing a response as to where it is running. So I'm just going to run this. It runs every 3 seconds, this curl. So as you can see, my response of the sample app is coming from data center on the west side, right? So let's do a failover. So I'm going to delete that app from here, right? So I'm just going to delete that application which I had on the primary cluster, which is on the west side. So I'm going to delete it. So as you can see, as it is deleted, there is downtime. It can't get a response back for some time, and then it should switch back to east because of the policies which you have applied. So there you go. So it changed from cluster west to cluster east. So a failover happened. And since it is primary, if the app comes back online, it gets a preference. So you will see that the traffic will be switched in some time from east to west. Switching from the backup to primary takes a while because it makes sure that the monitoring picks it up and it is not just a jitter, right, where the app comes and then you lose the connectivity again. So it waits for some time, but then you can see that it is now moved to the west zone as well. As soon as it found that the application was healthy, it moved back to its primary environment.